The Big Bang Theory says that in the beginning, there was nothing. Then it exploded. What exploded? Nothing exploded. How can nothing explode? Big Bang believers explain that nothing can explode and does. In fact, nothing did explode and made everything. That's why there's everything instead of nothing, because nothing exploded and created everything. There, see how easy that is?
Today's talk is Lesson 5, Big Bang Exploding the Myth. And last week we completed the created solar system. Next week will be even a bigger talk, which a lot of Christians have a rough time with this. Distant starlight, not a problem for a young universe. And we'll go over different scenarios where you could use that the Bible's true on the starlight coming to us. And then we'll switch to Series 2 on DNA and aliens, Lesson 7 on December 22nd, replacing Darwinism, New Origins of Species, Part 1. And then we'll take a holiday break and come back on January 5th, replacing Darwinism, New Origins of Species, Part 2. And then the last in this series is Lesson 9, Alien Intrusion, Unmasking the Deception. And we're seeing a lot of so-called alien news in the mainstream media, so this is appropriate for this time. But that'll be skipped a week. So today's Lesson 5, Big Bang Exploding the Myth. Now, when I talk about the Big Bang, I'm talking about the secular idea that the universe created itself in the Big Bang with no creator being involved. So the outline: first, we'll review the 3 lines of evidence that the secular scientists claim are support for the Big Bang model. Second, we'll look at several reasons why the Big Bang is actually bad science. It turns out that a closer look at the evidence actually discredits the Big Bang instead of supporting it. Third, we'll go even further, and I think you'll be shocked what I show you. We will look at the full implications of the Big Bang model. We'll see that the Big Bang is not good science. It's not bad science. It's actually anti-science. When taken to its logical conclusions, the Big Bang model makes science itself impossible. So if science is a valid way to describe how the universe works, then the Big Bang model ultimately must be false. I'm using clips again from Spike Pizarro's on a different video called Astronomy, Our Created Universe. I'm also using some clips from Evolution's Achilles Heels by Creation Ministries International, and a third video titled Astronomy Reveals Creation from Dr. Jason Lisle. Let's first start with a short clip on what is the Big Bang, and Spike will explain it with some video.
The universe is about 13.7 to 13.8 billion years old. Supposedly, in the beginning, there was nothing. And then suddenly, there was something. The universe burst into existence in an event now known as the Big Bang. At first, the universe was filled with radiation, and then as it expanded and cooled, matter began to form as gas. This gas was about 3/4 hydrogen and 1/4 helium, with maybe trace amounts of lithium and beryllium, but nothing else. As time progressed, this gas started to clump together to become the first stars. These stars clumped together to become the first galaxies. As billions of years passed, other stars and galaxies formed. One of them was our own Milky Way. Within the Milky Way, a smaller cloud of gas collapsed, which formed our solar system. And within the solar system is the planet Earth, where we are today.
Now, what's the Bible teach? We all should know this pretty well. We start off with Genesis chapter 1, verse 1. In the beginning, God created the heaven and the earth. Exodus 20, verse 11. It says, "For in 6 days the Lord made heaven and earth, the sea, and all that is in them." Genesis 1:16, we read about day 4 when God created the stars. Then God made the 2 great lights, the greater light to rule the day, which is the sun, and the lesser light to rule the night. He made the stars also. Again, it's like no big deal. We have a billion galaxies, a billion stars in each galaxy, but to God, that's nothing. And in Isaiah 45:12, it says, "I've made the earth and created man on it. My hands stretch out the universe, and all their host I have commanded." we'll talk about the universe is actually being stretched. You have the different galaxies moving farther and farther away, and we'll talk about that on what's called a redshift. Also in Colossians 1:16, for by him all things were created that are in heaven and that are on earth. So this explanation for the universe is not the one you will hear endorsed in science programs, science textbooks, or even science conferences. In fact, in our society today, we are often told that it is illegitimate to use the Bible to understand the history of the universe. The biblical account of creation is supernatural. What does it mean? Super means above or beyond, so it means above or beyond the natural world. And most scientists today insist that only natural explanations are allowed in science. But previous generation of scientists believed in the Bible and the account of creation. In fact, some of the most famous scientists that started the modern scientific thinking were all Bible-believing Christians, and they believed in the biblical account of creation and did not hold to what's called naturalism. And I'll play a video by Spike where he talks about the historical view of Bible-believing Christians, and he'll go through some famous names, and you've probably heard of some of them.
Now, previous generations of scientists didn't think this way. In fact, most of the giants of science, great scientists like Kepler, Newton, Euler, Pasteur, Faraday, Maxwell, and many others, all believed strongly in the Bible and in the biblical account of creation. They saw no problem doing science with the biblical outlook. Nevertheless, the reigning outlook in science today is naturalism, the idea that only natural explanations are allowed. For example, the University of California at Berkeley has a website called Understanding Science that explains it this way. Modern science does not deal with supernatural explanations because they are not scientifically testable. In other words, there's no way to gather evidence that would help us determine whether or not the explanations are accurate. We're told that the biblical account of creation doesn't meet this standard, and so it's disqualified. In fact, we're told that we don't need the creation account anyway, because we have a natural explanation for the universe, the Big Bang model. And we're told that this explanation is based on good science. But is it really? Let's take a look.
I'm going to play another short clip from Dr. Jonathan Sarfati, and he talks about how cosmology now is not observational science.
Cosmology is not real science in the sense of regular, repeatable, testable science, because cosmology is about a one-off event, supposedly the Big Bang. It happened one-off in the past. We can't repeat it. We've got no other universe to test it with. We've only got this one universe. So really, cosmology falls out of the definition of real science.
So the Big Bang model is based on three primary lines of evidence. 1, redshifted light from faraway objects. 2, abundance of light elements in the universe, in other words, the amount of hydrogen, helium, and lithium that exists. And 3, the cosmic microwave background. Now, some of these concepts might be unfamiliar to you, so let's go through them briefly. Let's talk about redshifted light. When you shine a beam of light through a prism, what happens? Exactly. The prism will break up the white light into the various colors of the rainbow. Astronomers use spectroscopes or spectrometers to do similar things. So sunlight contains a wide spectrum of wavelengths or colors, and they range from, you see on the bottom there, violet to red. So those are all the colors that we can see with our eyes. Now, there's lines of missing color, or absorption lines, in the rainbow. Sunlight passes through the sun's atmosphere, and some of those elements are absorbed, and they absorb specific colors. These colors are absorbed or missing from the sunlight. So each element absorbs its own set of colors, which tells us which elements are in the sun's atmosphere. So our sun's light produces a solar spectral pattern like the one you see on the screen. You can see faint black lines because that tells you that the sun absorbed, the chemicals in the sunlight absorbed that. A second spectral pattern is from a distant galaxy, are made up of the same elements as the sun on the bottom there. Spectral patterns are similar, which means the sun and the star from a distant galaxy are similar. But notice the patterns do not line up exactly. Notice how you have the line shifted to the right, to the red side. So spectral lines of distant galaxy are shifted to the red spectrum. This is called a red shift. And I'll let Spike talk about red shifts in more detail and how it ties in to the Big Bang.
The patterns don't line up exactly. The spectral lines from the distant galaxy are shifted toward the red end of the spectrum. This is called a red shift. Light gets red shifted when the object that's emitting the light moves away from the observer. You can think of it as the light waves getting stretched out. On the other hand, light can also be blue shifted when the object emitting the light moves toward the observer. You can think of it as the light waves getting bunched up as they travel. We see then that we can measure starlight from distant galaxies and see if it's red shifted or blue shifted. If it's blue shifted, the galaxy is moving toward us. If it's red shifted, the galaxy is moving away. And it turns out that except for a few close by galaxies that are blue shifted, every other distant galaxy we can see is red shifted. In other words, except for a few close neighbors, every other galaxy we see is moving away from us. And it appears that the farther out a galaxy is, the more red shifted its light is. In other words, the more distant galaxies are moving away from us faster than the ones that are closer. Now imagine what this means. If all the galaxies are moving away from each other, then the universe is expanding, and it's getting bigger as time goes on. The opposite is also true. If galaxies are moving farther away as time goes on, this means that they used to be closer together in the past. If you can mentally run the movie backwards, you'll see that eventually you reach a time when all the matter in the universe was at the same place. And this idea is the basis of the Big Bang model. The Big Bang model basically says that all the matter, all the physical stuff in the universe, started out compressed into an extremely tiny point in space. And not just the matter was compressed. The entire universe, all of space itself, was compressed into a single point. Then it suddenly exploded outwards, and that outward motion continues until this day, although the rate has changed somewhat over time. This is supposedly why we see all the galaxies still moving away from each other today, because space itself is still expanding.
Of course, we also see in the Bible, the verse I showed you, that God stretched the heavens. So God's doing that, separating the universes, making them go farther and farther away. The second line of evidence is called the abundance of light elements. And secular astronomers tweak the Big Bang model to a point where it can supposedly account for 3 light elements like helium, hydrogen, and lithium. They're all in the same concentrations that we see today. The third line of evidence is the cosmic microwave background. This was based on a prediction made in the 1940s and 50s. Few astronomers realized that if the Big Bang was true, we should see leftover low-temperature radiation from it. So in 1964, the discovery of the microwave radiation coming to Earth in all directions in space. This is known, as you see the picture there, as the CMB, cosmic microwave background. And microwave radiation is the same temperature everywhere in the universe. Note that the temperature color differences represent 1 1/1000th of a degree. So this will become a problem later, because that's saying the whole universe, the temperature is uniformly distributed perfectly. The CMB discovery was Big Bang's crowning glory. Other secular cosmologies of the time were quickly abandoned. Big Bang became the dominant model among secular astronomers because it matched the known evidence, the redshifts we're seeing, the light elements, and made a CMB prediction which was supported by later observations. So the Big Bang model became the dominant model. Most secular astronomers today believe that this proves the Big Bang to be correct. But there's more to the story, much more, and you'll see. Okay, that was point 1. Point 2 in our lesson, the Big Bang model is actually bad science. To assess the validity of the Big Bang model, we need to examine it in more detail. Let's start at the beginning. Why is the Big Bang model bad science? It tells us that the universe came from nothing. Spike will talk more about the Big Bang, where nothing created everything.
The Big Bang Theory says that in the beginning, there was nothing. Then it exploded. What exploded? Nothing exploded. How can nothing explode? Big Bang believers explain that nothing can explode and does. In fact, nothing did explode and made everything. That's why there's everything instead of nothing, because nothing exploded and created everything. There, see how easy that is? Of course, saying that nothing created everything doesn't work.
So could nothing create everything? That seems absurd, doesn't it? Nothing can create nothing, right? Nothing can do nothing. From nothing, nothing comes. R.C. Sproul once said, if there ever was a time when there was truly nothing, there could never be anything. So when you confront secular cosmologists, they will just shrug their shoulders and state what existed before the Big Bang is meaningless. Who cares? Time itself didn't exist before the Big Bang, so can't ask about conditions before the Big Bang because there was no before the Big Bang. There was no then. A Harvard astrophysicist explained, what came before the Big Bang might well be a meaningless puzzle, since at the beginning of the universe, matter, energy, space, and time probably all came into being. The concept of time before the Big Bang is quite possibly nonsense. To most cosmologists, asking what happened prior to the Big Bang is akin to asking what lies north of the North Pole. In other words, we're not allowed to ask them how the Big Bang could have happened, because it just did. The Big Bang happened because it happened. Since there was no nothing that could have created the universe just created itself because it created itself. Now, this reasoning's not logical. Something cannot create itself. In order for something to do anything, it must first exist. Self-creation would mean the universe would have to exist before it existed. So this whole thinking is obvious nonsense. The late astrophysicist Stephen Hawking, anybody heard of Stephen Hawking in the room? Yeah, okay, I see people nodding and raising their hands. He claimed gravity is responsible for the Big Bang. This is what he said. Because there is a law like gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing, why the universe exists and why we exist. He further explained, the laws of gravity and quantum theory allow universes, plural, I'll get to that, to appear spontaneously from nothing. Note, he is saying the laws of physics are responsible for the universe creating itself. Is this a good explanation? The answer is no, for several reasons. And we'll get back to why he said a plural of universe. Skip will talk about the laws of physics, how laws of physics, like dropping something on the ground, and Newton put a formula to gravity, that can't create anything. We're just explaining what we see in the natural world. But they can't create the universe, and he'll talk about that in detail.
What is a law of physics anyway? What does a law of physics look like? What does it sound like? What does it feel like when you hold one in your hand? Obviously, these are all ridiculous questions. The laws of physics are not physical things. So what are they then? Laws of physics are patterns that we've observed about how the universe works. For example, if an object is held above the Earth and then released, it will fall, and it will do that over and over again each time you repeat the experiment. Because it does this consistently, we can measure how it happens and then describe it mathematically, as Isaac Newton did when he first wrote down his formula for gravitation. But again, this formula is not a physical thing. It can't create anything because it's merely our description of how the universe works. It's merely our description of the universe's pattern of behavior. Now let's apply this to the Big Bang model. According to this model, before the Big Bang, the universe didn't exist. Well, if the universe didn't exist yet, then its patterns of behavior didn't exist yet either. so they couldn't have been involved in the universe's creation. And so, secular cosmologists are still left with no way for the universe to create itself from nothing.
And we'll go into some examples here. Lawrence Krauss, in his book, A Universe from Nothing, that was the title, tries to justify the nothing that is really something by claiming a quantum theory of gravity is responsible for the universe creating itself. He said a quantum theory of gravity allows for the creation, albeit perhaps momentarily, of space itself where none existed before. Note, he fails to mention that a quantum theory of gravity does not exist in physics. It's an invented term. Later, of course, these scientists are fully aware of this fact, but later in an interview, he admits, I also don't have a quantum theory of gravity, so I can't tell you for certain how space comes into existence. So even though some cosmologists claim the laws and theories of physics would allow our universe to create itself, this claim is false, as they themselves admit, as he admitted later in an interview. In addition to the Big Bang model not being allowed by physics with the universe from nothing, it goes much further by violating some of the most important laws of physics. This is key. Remember this. It may come up later. The law of conservation of mass and energy. This law says the total combined amount of mass and energy in the universe never changes. In other words, it cannot be created or destroyed. Mass and energy can only be converted back and forth, but they cannot be created or destroyed. This is one of the most fundamental foundation laws of science. If you take in a physics class, if you get the equation wrong, you fail. It can't be violated. We can also demonstrate this with Einstein's matter-energy equivalence. Anybody ever hear of the equation E equals mc squared at all? Yeah. Okay, so we see some. So I'll go over what it means. E is energy at rest. M is mass, or the amount of matter. C is the speed of light, and that's a large number. And you square a large number, you get a really large number, okay? So you can convert a little mass on the right side into lots of energy, because you're multiplying mass times a very large number, you get a big E. You can also convert a lot of energy into a little mass, and I'll show you how we do that. Converting mass to energy, we do this through a nuclear explosion. A small amount of matter releases a tremendous amount of energy with a nuclear explosion. Also, we can convert energy to mass in particle accelerators.
We do this in particle accelerators. Tiny particles get accelerated to almost the speed of light and then get smashed together. More material comes out of those collisions than went in. The particles' kinetic energy, the energy contained in their motion, gets converted into matter. So again, we can convert matter to energy and energy to matter, but we can never destroy either one, and we can never create either one.
And a physics textbook states, conservation laws are the guiding principles of physics. They are absolute conservation laws. They are always obeyed. So we see the effects of this law every day in our life. In physics, as I mentioned, solving an equation and you violate this law, it'll result in an incorrect answer. And if you keep making several incorrect answers, you'll fail. This is an example of operational science at work, which is testable, repeatable, falsifiable. It's math equations. So, let's see other effects of this law in our life every day. Why do you need to eat food? Your body can't create energy from nothing. It needs to get it from the chemical energy stored in the food. Why do you pump gas into your car? Does your car run forever? Your car can't create energy from nothing, right? It needs to get it from the chemical energy stored in the gasoline. Why do you get an electric bill every month? Your electrical devices in your home can't create energy from nothing. You get the energy from the electric company. And the electric company can't create energy from nothing. They receive it from the coal, natural gas, nuclear, and other intermittent energy sources like solar, wind, and hydroelectrical, etc. In fact, you couldn't watch this presentation right now if this law wasn't true. You're watching this on electrical devices, this computer, that projector, and these are key principles of electronic circuit design are based on this law. But we look at the Big Bang model, it violates this law, and it violates it on the largest scale possible, universal scale. It states that all energy and matter contained in the universe were created from nothing. Therefore, the Big Bang contradicts physics in the most fundamental way possible. What does the Bible teach regarding mass and energy? Let's start with John chapter 1, verse 3. It states, all things were made through him, and without him nothing was made that was made. So God created mass and energy during the 6-day creation. Genesis 2, verse 2, it says, and on the 7th day God ended his work which he had done, and he rested on the 7th day from all his work which he had done. So mass and energy, again, were created during the 6 days of creation. The law of conservation of mass and energy was established after creation on day 7 because God ended his work and rested on the 7th day from all his work which he had done. The matter and energy cannot be created or destroyed after creation because God created matter. He created energy. Therefore, no new material was made post-creation as defined in Genesis 2:2. Let's go further. What about Hebrews 1:3? God is upholding all things by the word of his power. So God upholds the law of conservation of mass and energy. Material continues to exist. And you're not going to see things popping in and out of existence because God's upholding everything he created by his power. Colossians 1:17 says, in him all things consist. So these two things together is what we call the law of conservation of mass and energy. It's very consistent with the Bible. Physics and the Bible are totally compatible with each other. Material continues to exist. That was what you would expect. Physics, observational science, and the Bible all in harmony. Therefore, creation is good science. So praise the Lord. In contrast, the Big Bang violates physics, observational science, and the Bible. So the Big Bang violates all three. Therefore, the Big Bang model is bad science. And I'll play a short clip from Dr. Jason Lisle where he reiterates this with what I just brought up, how this is consistent with the Bible.
Conservation of energy and mass. This is a little more abstract, but I do believe the Bible teaches this principle, that the amount of stuff in the universe, mass or energy, Einstein tells us mass and energy are basically the same thing measured in two different ways. The amount of stuff in the universe is constant. It can't be changed. You can't make energy, you can't destroy it, you can only transform it into other forms. And we would expect that because the Bible indicates that no new material is being created today by God. God ended his work of creation by the 7th day. He's done with creation. And nothing would simply pop into existence apart from God because the Bible says all things were made by him. Now, does this preclude a creative miracle? No, God can create new things, but for the most part, by and large, his act of creation, his work of creation is done. And so we'd expect that we wouldn't see new things just popping into existence from nothing. No new materials created, and God upholds what he's made. So you're not going to find stuff simply popping out of existence either. And these two principles together are what we call conservation of energy or conservation of mass. And we find that, lo and behold, that's exactly what the universe does. It's consistent with the scriptures.
Now let's talk about the three major predictions by the Big Bang model that failed. One is the magnetic monopole problem. Big Bang should have produced many magnetic monopoles. That means a magnet, you have negative and positive ends. A monopole means you only have one magnetic end, and magnetic particles with one pole. And according to the Big Bang, that should fill the universe with this. We don't see a single magnetic monopole in the entire universe. It's never been found. Also, the CMB, cosmic microwave background horizon problem. The Big Bang predicts large temperature irregularities in the universe, but they're not there. In fact, the temperature differences are so minuscule, like I mentioned, and the color differences on this graphic represent only 1/1000th of a degree temperature change. You can't even feel that. That's how uniform the temperature is across the universe. There's also a problem in geometry of space. The Big Bang should have produced a universe with massive positive curvature, almost like a sphere, or massive negative curvature, almost like a tunnel. However, the universe is flat and contradicts the Big Bang's prediction. So we have 3 predictions and 3 failures. Each of these problems contradict the Big Bang's predictions. Each one presented a fatal challenge to the model. Well, the Big Bang cosmologists invented a rescuing device called inflation, and we call it a failed solution to Big Bang problems. And I'll play this clip where Spike will discuss what inflation is.
So cosmologists were relieved when in 1980, a cosmologist named Alan Guth proposed a radical new idea that is now called inflation. Inflation says that right after the Big Bang occurred, the entire universe grew explosively for a very short time. Actually, grew isn't really the right word. We're talking about the entire universe exploding in size at multiple times the speed of light. As one physicist explained, at this rate of inflation, a region of space the size of a pea would be stretched larger than the observable universe in a time interval so short that the blink of an eye would overestimate it by a factor larger than 1,000,000 billion billion billion. And it turns out that for various reasons, inflation supposedly resolves all 3 of the problems I just mentioned. And so, inflation is a vital part of the Big Bang model today. It's the only explanation cosmologists have found for these 3 fatal problems. But it turns out that inflation has failed and doesn't actually rescue the Big Bang from its problems after all. First of all, it's important to note that even if inflation were true, it still wouldn't solve the Big Bang's other problems outside of these 3. For example, it doesn't help solve the problem of everything coming from nothing. As Guth himself has admitted, inflation itself takes a very small universe and produces from it a very big universe. But inflation by itself does not explain where that very small universe came from. Second, cosmologists have no explanation for how inflation could have occurred. There's nothing in physics that can explain this process. Supposedly, inflation was driven by a particle called an inflaton. But has anybody ever seen an inflaton? No. Is there any room within particle physics for an inflaton? No. Is there any justification for believing in the inflaton, or inflation overall, other than the fact that the Big Bang model needs it? No. As one physicist admitted, inflation's theoretical underpinnings may be rather tentative. The inflaton, after all, is a hypothetical field whose existence has yet to be demonstrated. And as an article in Astronomy magazine explained, what drove inflation? Nobody knows. Physicists have suggested different models to describe the inflating universe, but all the solutions are mathematical conveniences with no particular physical basis. All the theories of inflation amount to proof that we don't have one good theory yet, says this astrophysicist. So inflation is the name given for a hypothetical process that's never been observed, based on a hypothetical particle that's never been observed, and that has no basis in physics. But according to secular cosmologists, even though inflation has no basis in physics, it must have happened, because otherwise the Big Bang model would be falsified, and we know the Big Bang model is true. See the reasoning here? Secular cosmologists often say that we know inflation happened, because otherwise the Big Bang model would have the monopole problem, the horizon problem, the flatness problem, and so on. But that's a logical fallacy. Evidence against the Big Bang model is not evidence for inflation. Overall, inflation is a belief that's driven not by good physics or even by good logic, but merely by a desire for the Big Bang to be true. In other words, to explain away some of the fatal problems in their model, secular cosmologists are invoking something that's unknown to science and that has no apparent basis within science. That's not a scientific explanation. That's an appeal to miracles. Now, as a Christian, I accept that the creation of the universe was a miracle, done by an omnipotent, omniscient creator. But here we see that secular cosmologists also believe in miracles, even though they claim to deny them.
The fourth item that's bad science. Along with problems like these, the Big Bang has problems with physical evidence. Things that we see in the universe, like unexplained dark matter and dark energy. I showed this before when we talked about the galaxies. Each galaxy, as we see in space, has a spiral arm. But if they were billions of years old, these spiral arms would have decayed a long time ago. So here's a sample of a spiral galaxy winding. They can't last billions of years because the arms would rotate, the intersections would rotate fast, outer bands slow down, and the structure becomes tighter and tighter before dissipating, just like we see with like a hurricane. At 1 billion years, the galaxy would be twisted beyond recognition, and we would not see spiral arms. But evolution says galaxies are 10 billion years old, or 10 times the max age due to the theoretical max from the winding problem. And this is consistent with thousands of years. So with dark matter, that's the secular solution for galaxies continuing to hold their shape. Galaxy clusters do not appear to have enough mass to hold together gravitationally, especially for billions of years. So in galaxies, outer stars are rotating too quickly to hold themselves together for billions of years, like I mentioned. So they invented dark matter, which is 6 times the visible mass to hold the galaxies together than the actual matter that we can see. So matter we can't see or is invisible with dark matter. It emits no visible light. It emits no X-rays. There's no radio waves, nothing. Dark matter does not absorb or reflect light. In fact, light and radiation passes through it. For every galaxy you see, there would be 6 galaxies worth of dark matter that you don't see to keep the rotation going for billions of years. In fact, dark matter is outside of known physics, and astronomers frequently make comments like this. What exactly is it? What is it made from? Well, the simple answer is we don't know. No known particle fits the description. A Princeton cosmologist has commented, it's an embarrassment that the dominant forms of matter in the universe are hypothetical. One astrophysicist explained, really, we have no idea what's causing it. We so don't know what's causing it that we shouldn't even call it dark matter, because that implies we have some understanding that it's matter. We don't know what it is. I could call it Fred. 85% of all the gravity in the universe comes from something about which we know nothing. Let's rephrase that. 85% of all the gravity in the universe comes from something the Big Bang model knows nothing about. Another short clip on Spike talking about evolution's rescuing device, unexplained dark energy. We have dark matter to explain why the universe keeps spinning, even though they're supposed to be billions of years ago. Now they're going to invent another rescuing device called dark energy.
In the late 1990s, astronomers were studying some faraway supernovae. Supernovae are enormous explosions in space that occur under certain circumstances. For example, if a white dwarf star pulls material off of a companion star, it can only do this until a critical threshold is reached. At that point, the white dwarf quickly explodes in a massive, violent catastrophe. Anyway, astronomers were studying these supernovae, and they discovered something unexpected. The astronomers calculated the distance of the supernovae by measuring the brightness of the explosions. Then they calculated the distance that the Big Bang model predicted based on the redshifts, and the distances were slightly different. What does this mean? Well, according to the Big Bang model, this means that not only is the universe expanding, but the expansion rate is also accelerating. In other words, it's not only getting bigger, it's getting bigger faster and faster. According to the Big Bang model, All of the space in the universe must be filled with some kind of anti-gravity energy, driving the universe into expanding faster and faster, even though mutual gravitation among all the galaxies would otherwise prevent this. The Big Bang model requires a tremendous amount of this energy, filling the entire universe and growing as the universe itself expands. So what is this mysterious anti-gravity energy that the Big Bang model requires? It's become known as dark energy, not because it's something that looks dark, but because it's similar in some ways to the concept of dark matter. Just like dark matter, it's outside of known physics. Nobody has ever seen any, and nobody has any idea of what it could possibly be. Twice as abundant as all the physical mass is, about 68% of the total mass energy of the universe. As an article in Astronomy magazine explained, to get enough oomph, that's a technical cosmological term there, to drive the present acceleration of the universe, dark energy must make up about 68% of the total density of the universe. The biggest problem with this idea is that no one has any idea what dark energy is. So far, all we've been able to do is name it. So what exactly is dark energy? The obvious answer is, again, we don't know. Actually, the situation is even worse. We really don't know. Although cosmologists have adopted a cute name, dark energy, for whatever is driving this apparently anti-gravitational behavior on the part of the universe, nobody claims to understand why it is happening, or its implications for the future of the universe and of the life within it, despite thousands of learned papers, scores of conferences, and millions of dollars worth of telescope time. The nature of dark energy is now perhaps the most profound mystery in cosmology and astrophysics, and it may remain forever so. Let me repeat, we don't actually observe any dark energy in the cosmos. The only things we observe here are the brightness of the supernova explosions as seen from Earth, and the redshifts that we measure in the light. So dark energy is not something that's observed. It's just an interpretation of the observations that's required by the Big Bang model. So once again, the Big Bang model requires something that is completely outside of known physics. In this case, anti-gravity energy. And once again, the Big Bang model has no explanation for what it is or how it formed.
So the Big Bang model is a theory of everything. On this graphic, the visible universe, or all the matter, makes up 4 to 5% of the universe. That's the stars, the planets, and the galaxies that we see. Dark matter, which is the Big Bang model requires but doesn't explain, makes up 20% of the universe. 27% of the universe. Dark energy, which the Big Bang model requires but doesn't explain, makes up 68% of the known universe. The Big Bang was supposed to explain where the universe came from. In other words, it was supposed to explain the origin of everything. But here we see the model does not actually explain everything. Even if the Big Bang was good science, it could only explain 4 to 5% of everything. Do you really have a theory of everything? The answer should be clear. Secular scientists are unhappy. One astrophysicist has complained, it really is strange and to our perhaps uneducated eyes, arbitrary, ugly, or accidental to live in a universe where only 4% of matter is ordinary matter. I find awkward at best, implausible at the least, but there it is. If I didn't have all the facts in front of me and you came up with a universe like that, I'd either ask you what you've been smoking or tell me to stop telling fairy tales. You can tell they don't really hold to this. Today's standard model of cosmology has become an ugly mishmash compromising the basic Big Bang theory, inflation, and a little generous helping of dark matter and dark energy. Another cosmologist said, in no other field of physics would this continual recourse to new hypothetical objects be accepted as the way of bridging the gap between theory and observation. But the Big Bang theory can't survive without these fudge factors. Short clip from Dr. John Hartnett, where he talks about the Big Bang is not experimental science.
You might ask this question, why with all the modern technology, supercomputers, we have large telescopes with adaptive optics, we have space telescopes, why haven't we found the observational evidence to firmly establish the Big Bang without invoking all these unknowns? To believe in the Big Bang, you have to take it on faith. There's certain things you have to assume as given, without which you can't even make a calculation. How do you get to the ludicrous situation of 96% of the universe made up of stuff we know nothing about? Cosmology is not experimental science. In fact, I would go so far as to say cosmology is not even science. It's a philosophy, it's a religion, a worldview, it's a belief system. It's not science at all.
The fifth example of bad science: unexplained, finely tuned universe. Our own universe is an extraordinary place that appears to be fantastically well designed for our own existence. The specialness is not something that we can contribute to lucky accidents, which is far too unlikely. The apparent coincidences cry out for an explanation. So scientists calculate how finely tuned the Big Bang had to be. And the probability to get this number randomly is 1 part in 10 to the 60th power. And we'll break that down. So the planets, stars, galaxies of our universe are made of atoms. If the Big Bang actually created our universe, then it created 10 to the 80th power of atoms. If this creation event had to be finely tuned to within 10 to the 60th power, then the number of atoms could only vary to 10 to the 20th power. So what does that mean? Did you know that 10 to the 20th power is the same number of atoms contained in a single grain of sand? A single grain of sand. This calculation showed that the Big Bang model could not tolerate any variation more than a single grain of sand. This is the impact of the fine-tuning on the Big Bang model. So, if the Big Bang model created 1 extra grain of sand in the universe when it exploded, the universe would have collapsed into a black hole long ago. Too much weight. If the Big Bang created 1 grain of sand less, the universe would be completely empty, and space would have expanded too quickly, and galaxies would never form. Either way, if the alleged Big Bang created 1 grain of sand more or 1 grain of sand less, we wouldn't be here today. We couldn't be here. In other words, the idea that the Big Bang created our entire universe, the idea that a random event could be so precise that finely tuned down to a single grain of sand is ridiculous. Believe it or not, it gets worse. Believe it or not, when cosmologists added dark energy to the Big Bang model a few years ago, the fine-tuning got even worse. In fact, far, far worse, exponentially. It appears that dark energy has to be finely tuned to 1 part to the 123rd power. That's 123 zeros. Now we're talking about the fine-tuning that is far less than a grain of sand. If there are 10 to the 80 atoms in the universe, 10 to the 80th power, fine-tuned to 10 to the 123rd power, then the precision, the Big Bang's precision, had to be only a tiny fraction of the average of the atom of the universe, or down to 10 to the minus 43 third power. In other words, the precision required for the Big Bang is far, far, far less than a grain of sand. It is far less than the size of 1 atom, which is much, much less than a grain of sand. It's far less than 1/10 of an atom. It's far less than 1/100th of an atom. It is 1 divided by 10 to the 43rd power. So that is a ridiculously tiny fraction of mass energy in a single atom. That is how finely tuned the alleged Big Bang has to be now. Of course, this is why you see comments like this. For scientists who want to deny a creator, finely tuned dark energy discredits a random Big Bang so thoroughly that this one described it as a cataclysm for physicists. Well, we've seen, according to the Big Bang model, the universe is exceptionally fine-tuned. So how do secular cosmologists explain this? They invent the multiverse, which is the Big Bang's rescuing device for a finely tuned universe. Actually, they don't need one explanation. They think they have an infinite number of explanations thanks to something called the multiverse. The multiverse means multiple universes. The idea that our universe is not only the universe that exists, this probably sounds strange, but how can there be more than one universe, right? After all, the word universe means all that there is. Cosmologists have redefined that word. The word universe now refers to that part of reality that we could never perceive. So other universes refers to regions in the physical reality that are beyond our observation. Not just now or ever, even with the best conceivable telescopes, we can't see it. So the collection of all these universes are called the multiverse. And I have a video where Spike will go into depth where he talks about the multiverse and he gives you scenarios. There's different yous in these other universes. And you may have different breakfasts this morning. And maybe our country in a different universe, the Revolutionary War wasn't won by the U.S. Maybe Britain won in another universe and so forth. So you'll find this, I think, interesting.
Today's Big Bang model does produce a multiverse, and for more than one reason. For example, most cosmologists today believe that the cosmos has zero curvature and is infinite. This leads directly to a multiverse, because there would be an infinite number of universes we'd never be able to see. Most cosmologists also believe in inflation. It's an important part of the Big Bang model today. The original idea of inflation said that the universe inflated for a short time and then stopped, which supposedly formed our early universe. But cosmologists have realized that once inflation begins, it goes on eternally,
Never stops.
spawning an infinite number of universes as it goes. This goes on forever. Inflation will produce an infinite number of universes because it can never stop. The multiverse is now well established within cosmology, and even in popular science books. In fact, it's big business now. If you need some extra money, just write a book about all the universes out there that nobody can ever see. After all, who can prove you wrong? Anyway, most secular cosmologists are actually happy that the Big Bang predicts a multiverse, because they think it allows them to escape the fine-tuning problem. After all, if the multiverse contains an infinite number of universes, then it doesn't matter that our universe is extremely fine-tuned and appears to be well-designed and is outlandishly unlikely to have formed in a random Big Bang, because in an infinite number of universes, even the most unlikely universe will exist somewhere. And according to most secular cosmologists, we just happen to live in such an unlikely universe. As two cosmologists commented, this picture of the universe, or multiverse as it is called, explains the long-standing mystery of why the constants of nature appear to be fine-tuned for the emergence of life. The reason is that intelligent observers exist only in those rare bubbles in which, by pure chance, the constants happen to be just right for life to evolve. The rest of the multiverse remains barren, but no one is there to complain about that. Call it a fluke, a mystery, a miracle, or call it the biggest problem in physics. Short of invoking a benevolent creator, many physicists see only one possible explanation. Our universe may be but one of perhaps infinitely many universes in an inconceivably vast multiverse. Most of those universes are barren, but some, like ours, have conditions suitable for life. The idea is controversial. Critics say it doesn't even qualify as a scientific theory, because the existence of other universes cannot be proved or disproved. Advocates argue that, like it or not, the multiverse may well be the only viable, non-religious explanation for what is often called the fine-tuning problem, the baffling observation that the laws of the universe seem custom-tailored to favor the emergence of life. But even though this idea is popular among secular scientists, is it actually good science? Let's think about this. First, look at this sentence in the article. Critics say it doesn't even qualify as a scientific theory, because the existence of other universes cannot be proved or disproved. That's a correct statement. By definition, all the other universes outside of our own would be unobservable. Therefore, there's no experiment or observation you could perform that would either confirm or disprove this idea. In other words, the multiverse is not a theory that's open to scientific investigation. It's just an item of faith. Plus, think about the implications of the multiverse. If we live in an infinite ocean of universes, then there's an infinite number of universes that are almost exactly like the one that you're in now. Is there another copy of you reading this article? A person living on a planet called Earth, with misty mountains, fertile fields, and sprawling cities. You probably find this idea strange and implausible. Yet it looks like we will just have to live with it, since the simplest and most popular cosmological model today predicts that this person actually exists in a distant galaxy. If we live in an infinite multiverse, then there are an infinite number of universes, and everything that's possible has occurred somewhere. There's a universe where you are watching this video, and everything else is exactly the same as in this universe, except that you had something different for breakfast this morning. There's an infinite number of universes where the South won the American Civil War. There's an infinite number of universes where there never was a civil war because the original 13 colonies lost the revolution against King George III, and so on.
So hopefully you understand the multiverse implications. We'll go further. Now, I thought there's so much I hit you with, I should probably do a summary slide of what's the problems with the Big Bang model I didn't do before. Point number one, everything from nothing. Everything could not have come from nothing. This violates the law of conservation of mass and energy. The total combined amount of mass energy in the universe never changes. Point number two, some cosmologists who believe everything coming from nothing don't really believe there was nothing before the Big Bang. They actually believe there was something rather than nothing, like laws of gravity and quantum theory allow universes to appear spontaneously from nothing. That's what Stephen Hawking said. Lawrence Krauss said a quantum theory of gravity caused a universe out of nothing. So they really don't believe there was nothing. Nothing isn't really nothing. Point two, we talked about the Big Bang has three fatal problems: the monopole, the horizon, and flatness problems. 4, cosmologists try to solve this by invoking a short period of inflation earlier in the Big Bang, which is not observable, violates physics. Once inflation stops, it cannot stop and becomes an eternal process and produce an infinite number of universes. The inflaton is a particle that supposedly caused inflation, and the inflation is completely hypothetical, and the inflaton is completely hypothetical, and it's completely unknown to physics. Therefore, in order to rescue the Big Bang from its problems, cosmologists are invoking things that are outside of science. The Big Bang model also requires the universe to be filled with cold, dark matter, 27% of it. But the model has no explanation of what cold, dark matter might be or how it came to exist. If the Big Bang model is true, then the universe must be filled with some mysterious anti-gravity stuff that secular cosmologists call dark energy. That fills up 68% of the universe. The Big Bang has no explanation for what dark energy came to be or how it came to exist. Also, cosmologists claim that the Big Bang model explains everything, but however, it only explains 4 to 5% of the visible matter in the universe. This means 95% of the mass and energy in the universe remains unexplained. The Big Bang model requires an extreme amount of fine-tuning, and this is deeply embarrassing to the secular scientists who want to deny a creator. Remember, at first it was a grain of sand, and then it became 1 to this big number, divided atoms up. The Big Bang model also predicts a multiverse containing an infinite number of universes, which means there is an infinite number of copies of you in the multiverse spread throughout the cosmos. This supposedly avoids the fine-tuning problem, but all these infinite universes would be beyond our perception. So this is no way to investigate this idea to see if it's true. This means this idea is outside of science. So this is quite a list. The problems with the Big Bang model go far deeper than these listed here. I got 3 more points. The Big Bang model being anti-science. Point number 1, it's self-contradictory. It is from Spice.
And secular cosmologists admit that the subject of parallel universes is highly speculative. No experiment or observation has established that any version of the idea is realized in nature. The multiverse says there's an infinite number of universes outside of our own. By definition, all the other universes can't be perceived. They're unobservable. What word do we use to describe things that are outside of our observable universe? If they're outside of the universe we can see, then they're outside of the natural world, which means they're supernatural. That's what the word means, right? Outside of nature, beyond nature. But earlier we saw that the Bible was rejected as a possible explanation for the universe because it offers a supernatural explanation. Here we see that the Big Bang model is doing the same thing. In fact, do you remember that definition of science? Modern science does not deal with supernatural explanations because they are not scientifically testable. In other words, there's no way to gather evidence that would help us determine whether or not the explanations are accurate. Well, that description perfectly matches the multiverse. By definition, all the other universes can't be detected. And since the Big Bang model requires a multiverse, this means that the Big Bang model ultimately isn't scientific. Even some secular thinkers agree with this. These multiverse theories all share the same fundamental defect. They can be neither confirmed nor falsified. Hence, they don't deserve to be called scientific. Multiverse theories aren't theories. They're science fictions, theologies, works of the imagination unconstrained by evidence. Another said, "My own moral concerns about the multiverse have more to do with worry that pseudoscience is being heavily promoted to the public. If a wrong idea is promoted for enough years, it gets into the textbooks and becomes part of the conventional wisdom about how the world works. This process is now well underway with multiverse pseudoscience." After the initial period of creation, the biblical account of origins is consistent with both the laws of science and the practice of science. But the Big Bang model is not. Instead, the Big Bang model denies supernatural explanations, while at the same time, it requires supernatural explanations. Its claims to be science are self-contradictory.
Second point, absurd multiverse implications. We read in Matthew 7:20, "Therefore by their fruit you will know them." If the Big Bang model was a good model, then its fruit would be good science, right? If it's not a good model, then its fruit would be wrong or even absurd. So let's examine the fruit of this model. In a multiverse, there is an infinite number of planets with alien life. Includes planets full of non-extinct, evolving dinosaurs in another universe. This secular scientist said such life forms could well be advanced versions of dinosaurs. We would be better off not meeting them. So nothing worse than meeting dinosaurs with better weapons than you. The real multiverse means there are infinite universes where humans are fighting advanced dinosaurs at this moment. So is this science or science fiction?
Look out! There comes another one. I got him.
Other implications. Infinite number of planets with intelligent aliens on them. Some cosmologists propose that some aliens will have technology advanced enough to make new universes, including ours. One astrophysicist wrote, "It is proposed that our universe was created by life of superior intelligence existing in another physical universe. Intelligent beings might possess not only the knowledge to design, but also the technology to build universes. This explains why the constants of physics have their observed finely tuned values. Note, this is the reason our universe looks so well designed because aliens did it." So is this science or science fiction?
Science or science fiction?
Other cosmologists point out that in a multiverse, aliens don't actually build our universe. Our universe really isn't real. They say that our universe is only a simulation that aliens are running on their computers. One cosmologist wrote, "It is perfectly acceptable supposition that the world as we know it, it is a vast computer program run on machines built by an intelligence we know nothing about. If you accept the multiverse idea, it is almost inevitable that there are computer-based universes out there. Somewhere among the universes there would, in all probability, be universes where civilizations had developed far enough to produce a Matrix-style universe." And if you saw the Matrix, you know what he's talking about, the movie Matrix. "Chances are we do live in a computer simulation of a universe. Note, if you think our universe is real, now you are wrong." Now, is this science or science fiction?
So if you think our universe is real, you're wrong. It's actually just a video game being played by some alien somewhere. Do you think this sounds silly? Well, you shouldn't laugh, because this is a serious matter.
This is a serious matter.
Some cosmologists are working on ways to figure out if this is true. And this is important work. This research here was funded by the United States government via the Institute for Nuclear Theory, the National Science Foundation, and the U.S. Department of Energy. These are your tax dollars at work. But is it science? Or science fiction? But wait, it gets even better. If aliens can run computer simulations of universes, then they can also run computer simulations of universes that contain aliens that are running computer simulations of universes. So maybe our universe isn't even an actual computer simulation. Maybe the alien computer that's simulating our universe is itself part of a computer simulation, as this author said. There could even be multiple levels of simulation. The computer our universe runs on could be itself a simulation on another computer. And you could extend this on and on. Maybe the computer that's simulating the simulation is itself a simulation running on a computer that is itself a simulation running on a computer that is itself, well, you get the idea. Do I even need to ask if this is science? Now, not every cosmologist advocates things like our universe being a computer simulation being run by aliens. But the multiverse is completely consistent with this nonsense. And any idea that is consistent with nonsense is itself nonsense. If you accept the multiverse, this is where you wind up, in complete absurdity. Why then do cosmologists, intelligent men and women who claim to be doing good science, insist that such a ridiculous anti-scientific idea is true?
As one cosmologist warned, if there is only one universe, you might have to have a fine-tuner. If you don't want God, you'd better have a multiverse. Psalm 14:1, "The fool has said in his heart, there is no God." Now, do not misunderstand, most atheistic scientists are very intelligent people. The Bible is the foundation of wisdom and understanding. And Proverbs 9:10 says, "The fear of the Lord is the beginning of wisdom, and the knowledge of the Holy One is understanding." So when you deny the Lord in the Bible at the beginning of your cosmological model and try to figure out how it developed without God, you are denying wisdom. Therefore, you will end up in folly, and this is where the atheists are today. The final point, the Big Bang model refutes itself. Even if something could come out of nothing, you will not get our universe out of a Big Bang based on a quantum fluctuation. Instead, you will get Boltzmann brains. Boltzmann brains. What if the Big Bang's cosmic fluctuations do not make the entire universe? What if it only made your brain? Your brain popped into existence with false memories and false perceptions with the universe around it. A brain that is floating in the void thinking there is a universe but isn't. Why? Because it is all an illusion. It's hard to make the universe. This is when you see this, you'll think they flipped out. But this is what it comes to. This is something I can guarantee you have never heard. But this is what the Big Bang model logically leads to, this insanity. And I'll play this.
Now you might be thinking that this is one of the silliest ideas you've ever heard, and I would agree with you. But remember, we're thinking like secular cosmologists for a moment. Secular cosmologists have to believe that cosmic fluctuations can make things pop into existence. But according to the mathematics of their models, it's infinitely more likely for a single brain to pop into existence than for the Big Bang to have caused a baby universe to pop into existence. Here's how an article in the New York Times described this problem. It could be the weirdest and most embarrassing prediction in the history of cosmology, if not science. If true, it would mean that you yourself reading this article are more likely to be some momentary fluctuation in a field of matter and energy out in space than a person with a real past born through billions of years of evolution in an orderly star-spangled cosmos. Your memories and the world you think you see around you are illusions. This bizarre picture is the outcome of a recent series of calculations that take some of the bedrock theories and discoveries of modern cosmology to the limit. The basic problem is that it's hard for nature to make a whole universe. It's much easier to make fragments of one, like planets, yourself may be in a spacesuit, or even, in the most absurd and troubling example, a naked brain floating in space. Nature tends to do what is easiest from the standpoint of energy and probability. And so these fragments, in particular the brains, would appear far more frequently than real full-fledged universes, or than us, or they might be us. Alan Guth, a cosmologist at MIT, who by the way is the inventor of inflation theory and is a rock star among cosmologists, who agrees this overabundance is absurd, pointed out that some calculations result in an infinite number of free-floating brains for every normal brain, making it, quote, infinitely unlikely for us to be normal brains, unquote. Cosmologists call this the Boltzmann brain problem, named after the physicist Ludwig Boltzmann. Basically, according to secular cosmology, it's far more likely for us to be disembodied brains floating in space than for the universe itself to be real. The Big Bang model is still so mathematically improbable that a brain popping into existence from nothing is far more probable. Notice I'm not talking about this, a brain floating in our universe. But this, there is no universe. The cosmos is empty other than the brains. There are no galaxies, no stars, no planets, no sun, no Earth, just brains. In fact, cosmologists can't even be sure that there's more than one brain. You might be the only one. Maybe everything you think you see in the world around you, everybody else that you think you know, are all illusions. You're not really watching this video, because this video doesn't exist. Even though you think you're watching it, the input you're getting from your senses is an illusion. And even though you think you have memories of watching it up until this point, those memories are actually false, because your brain just popped into existence a few seconds ago. In fact, your entire life, from growing up as a child until now, didn't happen either, because all your memories are false. Your brain just happened to pop into existence with all the molecules arranged in such a way that it included all these false memories built into it. Oh, and by the way, you aren't going to live long, because your brain doesn't actually have a body to sustain it. So you'll die soon, and then your brain will dissolve back into the thermodynamic soup that you originally fluctuated from. Again, this might sound ridiculous. Well, that's because it is. But that's what the secular cosmological models say. In fact, cosmologists have had the Boltzmann brain problem in one form or another for a long time. And they have written lots of articles in the scientific literature trying to solve this problem and trying to escape the menace of the Boltzmann brains for the Big Bang model. But despite their efforts, the problem has actually gotten worse instead of better. Cosmologists have realized that eternal inflation, dark energy, and the multiverse all lead directly to Boltzmann brains. As long as any one of these things remains part of the Big Bang model, and they're all essential pieces of it, then the Big Bang model says we're infinitely more likely to be Boltzmann brains than normal people. As these physicists wrote, a typical observer in the multiverse is a Boltzmann brain. In the eternally inflating vacua, observers are infinitely more likely to be Boltzmann brains than honest folk like ourselves. So what does all this mean? The Big Bang Theory, when taken to its logical conclusion, means we're probably not real people. We're probably just Boltzmann brains. Remember, it's infinitely unlikely for us to be normal brains. This means that the universe we see is an illusion. It doesn't really exist. And since a universe which doesn't exist never had a beginning, this means there was no Big Bang. In other words, the Big Bang model ultimately says that the Big Bang is infinitely unlikely to have happened. And that means that the Big Bang model has self-destructed, because it's self-refuting. The Big Bang model disproves itself.
Okay, Romans 1:22, professing to be wise, they became fools. When you deny wisdom, it becomes folly. When you deny the truth, whatever you believe will be a lie. I appreciate your attention. Next week, we'll go into even more challenging for Christians, distant starlight. But I'm saying it's not a problem for a young universe. I thank you for your attention.